Good morning or good afternoon. It's Miss Bauer here, and today we're going to talk about parallel lines, transversals, and the angles that we have when we have those parallel lines and transversals. So first you really need to understand what are parallel lines. So we have this 3D picture here. Think of this like the classroom with points A, B, C, and D on the floor and points E, H, G, and F on the ceiling. This is going to give us a good idea of what parallel lines are. So parallel lines are lines that never intersect, but there is a catch there. Parallel lines are coplanar lines that never intersect. They're coplanar because typically we graph them, right? And so graphing them, that's the same plane, the same grid. So parallel lines are whenever we describe coplanar lines that never intersect. And our symbol for parallel is just this slash. So if we look at this diagram, we have a ton of options. We're just going to go through a few of them. But I could say AB is parallel to CD, and those are both on the same flat surface, the same plane. Those are both on the floor. I could say that AB is parallel to EF, and that's on the same front wall or back wall, depending on how you're seeing it. I could even say that AB is parallel to GH, because you could put a slide and that would still be coplanar. They're going the same direction. So essentially all of those lines would be parallel to each other, but you have lots and lots of options here. I could say that AE is parallel to HD or BF or GC. I could say that EH is parallel to AD or GF or BC. So I have lots and lots of options here. Let's go with AD. So if I were going to write line AD, I would write it just like this. So line AD, and I could say that's parallel, so slash slash, and let's go with GF. So I'm going to say that line AD is parallel to line GF, just like that. And I could do more, right? There's lots and lots of options here. I could say it's also parallel to EH, and so on and so forth. But parallel lines are coplanar lines that never intersect. Now, perpendicular lines do intersect, and by default, intersecting lines have to be coplanar. But perpendicular lines are lines that intersect at a right angle. So they just don't intersect at anything. They're lines that intersect at a right angle, or 90 degrees. That is a right angle. And keep in mind, for them to be perpendicular, for them to intersect, they have to be on the same plane. So for example, if I did the floor and I said, what's perpendicular to AB? Well, something else on the floor would essentially be perpendicular. AD would be perpendicular. I could say that AB and BC are perpendicular to each other. Think of the corner of the classroom. I could also say AB is perpendicular to EA. So I have lots and lots of options there, and our perpendicular symbol is just an upside down T. So I have so many options here. I'm going to go with line GC. So if I said line GC and I wanted to know what's perpendicular to line GC, so that perpendicular symbol is an upside down T. So what's perpendicular to line GC? Well, I could say FG. I could say GC and HG. I could say GC and BC. I could even say GC and DC, which is what I'm going to go with. And if we just look at that and I asked you, well, where do they intersect at? They would intersect at point C. Remember that two lines intersect at a point. So these coplanar lines are intersecting at point C. And I could see that just from the verbiage in the letters that I see. Now, skew lines are all over this picture, all over this room. Skew lines, if you could say the word ski and you could say the word ew, you could say skew. Skew lines would look like this. What if I had GC again and EF? Okay, well, GC and EF, those aren't parallel. They're not going the same direction, right? But they're also not perpendicular because they're not actually intersecting. They're not really intersecting right there. GC, think of it, that's like the front vertical part of the classroom, and EF would be on that back wall. And if you're in my classroom right now, just kind of think maybe GC is over there vertical behind the bookcase, the bookshelf in the front corner, and then EF is on that back wall way high above all of those posters. Those two lines are never going to intersect, so they're not perpendicular, but those also aren't on the same flat surface. One's on the front and one's on the back. Those aren't going to touch. And that's what skew lines are. Skew lines are non-coplanar lines that never intersect. They're non-coplanar lines that never intersect. And we don't actually have a symbol for skew lines. We would just say like is skew 2 and go from there. But think of skew almost like ninja arms, right? So like HE, well that's parallel, that's parallel, that's parallel. I can't touch it because that would be perpendicular. So that's perpendicular, that's perpendicular, that's perpendicular, that's perpendicular. But if I had HE and FB, that's an example of skew lines. I could say AD. So line AD on the floor over there is skew 2. And I have lots of options, but line AD could be skew to EF. They're going different directions and they're not on the same plane. They're not ever going to intersect. And for a lot of those, there's more than one answers. So you can't graph skew lines, but today we're really going to focus on essentially parallel lines. So if you have parallel lines, or even if they're not quite parallel, so maybe they look like that, you'll always have an inside part and you'll always have an outside part. But we don't say inside and outside, we say interior and exterior. So if you think of an Oreo and I asked you which part of the Oreo is on the interior, well that would be the cream. And which part is on the exterior, that would be the cookie part, like the chocolatey part itself. Or maybe the vanilla if you're into golden or lemon, lots of Oreo flavors there. Now, it doesn't matter how you turn your Oreo. The inside is always going to stay on the inside and the outside is always going to stay on the outside. And yeah, you might deconstruct it, but we're not going to be deconstructing lines. The interior will always be the inside and the exterior will always be the outside. But keep in mind that maybe my lines go this way, so this is the interior, or maybe my lines go like this and that is the interior. So it doesn't really matter how we turn the cookie. The interior is still the interior and the exterior is still the exterior. So once you have some lines, and they're not quite parallel, and that's okay. But once you have some lines, if I add a third line into the mix, that's when I really have my interior and exterior angles. Before, if I just had lines on the inside, there's no angles really on there. But once I add this piece, now I have 8 angles formed. And this line right here is called a transversal. You could think of your transversal like the toothpick that's holding the sandwich together. So that's a transversal. Think of it like the toothpick that's holding your sandwich together. Without that toothpick, that sandwich is going to fall apart. We're not even going to have angles. Your transversal is that line that intersects 2 or more lines. It's what creates all of those angles. And I could have a lot of lines, so I could have like 3 or 4 lines. Well, there's nothing really special about those until I give it a transversal, and now I've created all of these angles. So without that transversal in there, there's not really much that you can do. So if I were going to ask you which of these angles are on the interior, if you think of this like your sandwich bread, well, your interior would be 3, 4, 5, and 6. Those are our interior angles. And then 1, 2, and 7, 8 would be on our exterior. And when we talk about angle pairs, what we're really going to do essentially is we're going to pick one from the top set and we're going to see how is it related to the bottom set. So what we're doing is we're going to be picking one from the group up top, and then we'll pick one from the group below, and then we'll really see how they are related. So the first way that these angles could be related is if they're corresponding. And corresponding angles essentially means the same spot. So corresponding is like which angles pair up. So 1 is in the top left, well 5 is in the top left. So angle 1 and angle 5 are corresponding. I could go with 2 in the top right and 6 in the top right. So angle 2 and angle 6 are corresponding. And then I could also go with, in this group right here, 3's in the bottom left. 3 would pair with 7, which is also in the bottom left. So I could say 3 and 7. Or our last set, bottom right, that would be 4 would pair with 8. And those are what are called corresponding angles. Sometimes we'll abbreviate that with a C for short. The other way that these angles can be related is if we have alternate interior angles, or AI for short. Now, remember that for alternate interior, we have to pick one from each set. So if I go up here and I pick 3, 3 and 4 aren't alternate interior. I need to pick one from the second set down here. So 3 would be alternate interior with 6. I would cut across the transversal. So 3 and 6 would be alternate interior. So I could say 3 and 6, or I could go the other way and say that 4 and 5 are also alternate interior. There's alternate interior, there's also alternate exterior. And that would be AE for short. Alternate exterior would be if I had 1, go all the way across. 1 and 8 would be alternate exterior. Or I could say 2 all the way across and 7. So 2 and 7 would also be alternate exterior. Okay, there's alternate interior, but then there's also what's called same side interior, and some people refer to this as consecutive interior. Consecutive interior, same side interior, same thing. I like the word same side interior. I just feel like it flows a little bit better, or SSI for short. Same side interior would be like 3 and 5. Same side, but remember we're picking one from each set. So 3 and 5. Or 4 and 6. There's same side interior. Well, then there's also same side exterior. Or SSE for short. So that would be, for example, 1 is on the exterior. Well, what's on the same side, but also on the exterior? Remember, 1 from each set. So that would be 1 and 7. Or I could say 2 and 8. Now, let's say that we didn't have this second line down here. So we didn't have 8 angle pairs. Let's just say that we only had those 4. Well, that goes back to some of the stuff that we learned in Unit 1 that still exist here. What type of angles are 1 and 4, or 2 and 3? And hopefully you're remembering that those are vertical angles. Vertical angles are still existing. There's now just a lot more. There's 1 and 4. We said 2 and 3. But now I have a whole second set down here with vertical angles. So I could say 5 and 8 or 6 and 7 too. And that's old, and we can call that VA for short. But remember that vertical angles still exist. As long as you have 2 lines, you're probably going to have vertical angles. As long as those 2 lines intersect, they exist. We also have linear pairs still, so I'm going to call that LP for short. And that's not relating one set to the other. Remember that linear pair, they form a line. So I could just say like 1 and 2, those are adjacent and supplementary. Or I could say 1 and 3. I have lots of linear pairs. There's 1 and 2, there's 1 and 3, there's 2 and 4, there's 3 and 4, there's 5, 6, 5, 7, 6, 8, 7, 8. So essentially I have all of these lines. So I have lots and lots of linear pairs in the mix. So don't forget those old words as we're introducing new words. So let's take a look at what this would look like on a picture. I have lots and lots of lines here, and the A, B, C, D got cut off, so let's go ahead and add a lowercase a lowercase b, a lowercase c, and a lowercase d. Remember, lowercase letters for lines. In order for you to use one of these up here, your lines have to have a transversal that connect your set. So that's always the first thing to figure out is what's the transversal? What's the toothpick that matches the two sets that holds them together? So if I'm talking about angle 1 and angle 5, ask yourself, what's the transversal? What's the toothpick that holds it all together? It's not A, it's not B, but if I'm talking about 1 and 5, line C would be the transversal. It's touching both angles, it's holding it all together. And then if I asked you, well, what type of angles are 1 and 5? Well, if line C is my transversal, there's one set, there's the second set. Notice that 1 and 5 are both in the top left, so that would be corresponding. So if we were going to talk about angles 4 and 6, first we need to figure out what's your transversal, what's the line that touches both 4 and 6. And in this case, that would be line C. Again, so there's my set, I'm talking about 4 and I'm talking about 6. I can ignore all these lines down here and I have to ask myself, are 4 and 6 on the inside or on the outside? Well, they're on the outside and they're on alternate sides, so that would make them alternate exterior. And I'm going to abbreviate that to ALT-EXT. So if I talk about 4 and 10, well, now my transversal would be line A, and there's my sets, and I'll notice that they're both on the inside, but they're on alternate sides, so this would be alternate interior. So taking a look at the next one, 2 and 9, well, line A is my transversal. So there's my transversal, there's my set, so 2 and 9. And this one is a little bit weird because if you notice, 2 is on the exterior, but 9's on the interior. So if I go back to my list, they can't be alternate interior, exterior. They can't be any of those. They're not vertical angles, they're not a linear pair because one's on the exterior and one's on the interior. But they're also not corresponding either. Corresponding would be 1 and 9 or 2 and 10. So it means that while these angles actually have a transversal, they don't have any relation. So I'm going to say NA. And I'm going to give you a few more to try on your own, and then we'll check them in the next video. So I want you to try to figure out what are 3 and 13, what are 10 and 13, and then what are 12 and 11. And I'll see you in the next video.